Hey guys, welcome to this video where I'll be showing you how to create an API application using the FastAPI framework in Python. This is a relatively new web framework that competes with things like Flask and Django, except that it focuses specifically on the development of APIs. And for that purpose, I think that FastAPI offers the best performance and the best developer experience. If you don't know what an API is, then you can think of them as an HTTP endpoint that acts as the interface between your service, whatever that may be, and the rest of the world. APIs are pretty much the backbone of most internet services these days. You really can't go far without running into one. For instance, something like booking a room in Airbnb, requesting a ride from Uber, or writing a post on Twitter are all examples of an API in action. And as you can see, APIs can range from something really complex, like in those examples there, where behind the scenes they have to interact with a whole lot of different systems, to something really simple as well, like for example, an API could just be a function that adds two numbers together. And for our project today, we're going to be building a simple e-commerce bookstore API that lets us add and retrieve information about books from our server. So if you're ready, then let's get started. I recommend pulling up the FastAPI documentation by just searching FastAPI into Google, and then it's this URL over here, fastapi.tiangolo.com, and you should see a page like this. So this is where I get started from. And if you click on this tab on the right, there's a tab called installation, which should take you to the installation instructions. As you can see, it's just a simple command in our terminal, pip install FastAPI. So we'll go ahead and run that. And in this one, it actually recommends us install another module called Uvicorn as well, which we're going to need later to actually test and run the FastAPI server on our local machine. So I've opened up my terminal here, and I'm just going to type pip install FastAPI. And also pip install Uvicorn. So with FastAPI installed, we can now get started with coding the project. I'm going to open up this project directory in my IDE, which is VS Code. So that's just code dot. And now I have my project open here. And I'm going to start by creating a main.py file. Getting started with FastAPI is also really easy. If we go back to the documentation and then click on first steps, there's a really short code snippet. It's only about 5 lines long, and we just copy that. And that's all we need to create our first FastAPI application. So copy this and put it into your file. And now we can test it. So we'll run this command uvicorn main:app -- reload, and we should see something like this. So go to my terminal and run that. And now my server's started, and it says it's running on localhost on port 8000. So if I just click that to open, then I can see that my API is responding to this address, and it's returning me the message, hello world. Let's take a step back and see what we actually did there. In this script, we imported FastAPI and we created an app. And the name of this app is the argument that goes into our command line over here. So we're saying in the file main or in the module main, I want to run this as my app as a server. And I also have this function, which is actually an async function called root, and is returning my message, which if we go to our web browser and go to this address, we see this exact data. If we change this message, then that response would change as well. So for example, let me add another field here. So say var1234, and then I save that. If I refresh this page, I'm going to see that that new information is returned when I call this endpoint. So what does this actually mean? If I copy this endpoint here and bring it back to our project, this HTTP address, this is what's known as an API endpoint. It's basically just a public URL. Because I'm running this on my local machine, this is going to be only accessible to me. So nobody else on the internet can access this because this is on the local network. This is the home address. But I can deploy my API to be online so that if I put it behind a domain, for example, something like this, and then if people go to that URL, then they'll see this message as well. So that's when I actually deploy it to production. Now this URL is something, I guess we can call it as the root of the endpoint. So it's the root path, which means that whatever we put into this decorator here as the argument, that's the path that if somebody goes to that path, we want this function to run and this response to be returned. And if it's just a slash, then it usually just means the root path. For example, if I wanted to do something like have another function, like let's say get current time, like this, then this is going to be the path that I want it to run on. So I'll have to create another function But instead of the dash, I'll put this subpath in here instead. And then the current time is, I can put some number here. Something like that. Okay, I have to change the function as well. Okay, so now I have two functions and each are known as API methods. So it means that I can call either the root path like this one and I'll get this function executing, or I can call this getCurrentTime method and have this function execute. So let's try that and see if it works. Rerun my root path and it still works, still returning my hello world. And now I can try with getCurrentTime. And now it's returning a different message. And this is kind of just a quick overview of how we map different paths in the endpoint to different methods in our Python file over here. Obviously, if I try to go to a path that doesn't exist, for example, let's say foo, like that, then it's just going to be a not found error. Now let's erase all this so we can move on to the next part of the project. So now that we have written our first API and we know roughly how it works, let's talk about the application we want to build. I want to create something like an API for an e-commerce bookstore where I can see all the books I have in my catalog and maybe list them or add new ones, things like that. So first of all, let's write out the different paths we'd want. I am going to keep a root path here, maybe just for health checks and just as a hello world. I'll probably want something like a list books that if I call this path, it'll show me all the books I have in my catalog. Maybe something like book by index. So if I give it a specific number, then I can get that exact book and nothing else. And then this one, I actually want to have like the index number as part of the path. So like I'll use it like book by index /0 or 1 or something like that as an example. So maybe I'll do something like get a random book if I want to recommend random books to my customers. Maybe something to add new books to my library as well. So add a book. And this one, it doesn't have any kind of parameters here. As we're going to see later, we'll actually send data to this API through something called a request body. So that's why we don't have the input data here as we do in this one. And also finally, if I have the ID or the unique identifier of a book, I also might want an API to just get that book directly. It's going to use a query parameter. So if you see, sometimes you see HTTP URLs with this question mark behind it, and then you see something like ID equals, blah, 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 blah. So that's what we're going to do as well, where this ID, it's going to look it up in our system and see if we have it. And if it does, it's going to return us that book. So the first one is probably the easiest to implement. We already seen that from the example that we did before, but let's just go ahead and write it again. So it was going to be @app.get, and then it's just going to be our root path, and we'll have an async function called home, and we're going to have it return a message like this. So now if I go back to my browser and then refresh my API, I can see this message, welcome to my bookstore. Okay, so the next one is list books. So let's go ahead and implement that. I also recommend naming your Python functions after the API method so that these names should be the same. But this one is just a slash and we can't name a function that. So you can call this thing like home or index. But for every other method or path that you have, I recommend using that as the Python method name if possible. And this one's not going to take any parameters. And it's just going to return an empty list at the moment because we don't have any books yet. But let's just see if this works. Okay, so this just gives us an empty response. That's fine. To make sure that it's actually returning something, I might actually do something like this, books, and then give it an empty array. Now let's see again if that's a bit better. Okay, I like this. This is more explicit. Maybe I'll make this bigger so you can see. Now, another really nice thing about FastAPI is that it actually gives us a bunch of docs and a console interface to look at all our APIs that we have on the server. So if you just go to the root path and you type docs hash, you'll see that it loads these Swagger documentation for the API. So we can see our home here and our list books, and we can see that they are using the get method of an API. Back to my project now, I actually want this to be some kind of database, but implementing a whole database for this is out of our scope. So we're just gonna fake that with a global variable for now. I'm just gonna call it book database in all caps, like this. And I'll create it here as an empty array, and I'll put it here into my response. Now I can add a couple of books to this database. So let's go ahead and add some. Okay, so if I go ahead to my API and then click on this method here, I can actually try it out just using the web interface. And I can see information about it here. There's really nothing because it's just a get API. Then I'll press execute and I can see the response here. And you might notice there's a curl command here as well. So far we've been using our browser to interact with the API, but we can also do it programmatically using our terminal, using the curl command. So this is a good way to test it out. But this is also how you can interact with it from other applications or from another service that you might want to build. So let me try that in the terminal and see if it actually works. I have to leave this running because this is our server. So I'll open another terminal here and just copy that command. And then if I run that, I can see that even my terminal is able to interact with this API and get the response. Next up, let's see if we can get a book by the index that it is in the list. So for example, if I type in index 0, I should be able to get The Great Gatsby. If I type in 1, I'll get Atomic Habits. If I type in 2, I'll get Norwegian Wood. So let's implement that and see what it looks like. And here we're actually using this part of the path as our input. So to do that in FastAPI, we have to just put our curly brackets around it like this, call it index, and this tells it that whatever number or value that the user puts here, we want to use that in our function. So when I write my function now, I'll call it book by index, I actually want to accept a parameter. It doesn't have to be the same name. I can do it something like I, but whatever the user puts here will now be accessible as this function parameter. I'm gonna call it index anyways, and I can even type hint it to be an integer, so they can't put a floating point or they can't put a string, and we'll see what happens when they try to do that. But for now, let's actually just do this. And for the body of the function, I just want to return the book that is here. So we do this. Return the book that is at the index, like that. So let's go back to our API docs and refresh it. And we can see here, get book by index now shows up. And now we can put in an index. And FastAPI was smart enough to figure out from our type hint that this must be an integer. So if I click try it out and I try to put something like a string, maybe like that, it's gonna fail. If I put an integer like 0 and then execute, it gets me The Great Gatsby. Now, if I want to call it in my browser, I can try this as well. So with this request URL, I'll try this. And this should work. And if I change this number 0 to 1, then the book becomes Atomic Habits. If I change it to 2, it becomes Norwegian Wood. If I change it to a string, like maybe apple, and then run it, it gives me this error. Likewise, if I give it a number that's too high, I only have 3 books. So if I give it index 5, I've just crashed my server. And the reason is, if we look at this, we can see all the error messages here. This number 5 that comes in is actually out of range for our book database index. So this brings me to the next thing I want to show, which is how to handle and throw errors in your FastAPI application. This is really bad because whoever's using this API has no idea what happened. Internal server error is not very descriptive. And second of all, our app crashes, which affects other people trying to use the API. So how do we fix this? First of all, we need to detect when an index is out of range. And if the index is out of range, we don't want the app to crash, but we do want to respond with a more descriptive error message. So if the index is less than 0, or if it's greater than or equal to the length of the book database, then we need it to fail. Otherwise, we can return the index. To make FastAPI throw an error without crashing, we can use something called an HTTP exception. And if we just raise this exception, we can see that it has a status code and some details. So the status code, if you want to know which one to use, you can just type in HTTP status codes into Google, and then you'll probably find a table somewhere of common status codes and what they mean. These are the ranges. Anything begins with a 2 is usually a success code. Anything beginning with a 4 is usually a client error code, and 500 is a server error code. So anything that our users do wrong, then that should begin with a 4. Anything that goes wrong on our server side, that should be a 5. If we look at the client error codes, we've got bad request, unauthorized, payment required, forbidden, not found. So this not found is probably the one we want to use here, because we're saying that this index doesn't exist in our database. So we're going to use a 404 error code. Usually, also, I recommend if you're going to return an error to your clients, try to have a descriptive error message if you can. Even for yourself, it might help you debug your application. Saying something like index, whatever they passed in, is out of range. And then I'll put in the length of the database here as well, just so that we can debug this easier. Okay, so when I raise an HTTP exception from FastAPI, it doesn't crash the app, but this instead is shown to the user. By the way, you have to import this as well. My IDE did this automatically for me when I typed this, but if yours doesn't do that, then you have to add this to your FastAPI import here. So let's go ahead and run it again and see what happens this time. Okay, so I've run this again, and now my server doesn't crash, and I get an error message that is much more helpful, saying that index 5 is out of range 3. Now the next method I have on my list is getting a random book. This is pretty straightforward to implement as well. It's just a bit of fun, and it just shows us that we can have the API do some kind of custom logic on the server side. In this case, we're just getting a random book, but you can imagine what you can do with this. For example, you could make a fitness app that produces a random workout, or a cooking app that if you give it certain ingredients, it tells you what you can make with it, things like that. So let's go ahead and implement this, and this is going to be really easy. We're just going to call it getRandomBook, and the function name will be the same, getRandomBook. And we're going to use the Python random library, so we'll do import random, and I'll use the method called choice and pass in my book database. So this will just pick a random element out of this. Let's test that one out. Okay, so this time I got Norwegian Wood. If I refresh it, I'll get the Great Gatsby and so on. It can just changes every time the API is called. And if we go back to our documentation page and refresh it, and you can see that all of these 4 methods we've added are here as well. The next method I'm going to implement is called addBook. So this one, we want to give it some information and then have that actually be added into our database. And this is where things get a little bit different, because the 4 methods that we've created so far have been using the get method, which basically says that we're just retrieving information. We're not modifying or adding any information. And with HTTP REST request methods, there's a few of them. There's get, post, put, patch, delete, things like that. So these are the standard ones, and then you can just look it up online to see what each of them are supposed to do. But the ones that you see being used the most are usually get and post. So get is when we want to retrieve some information, and post is when we want to add or append new information under a data structure. So in this case, we're appending a child piece of information under the book database. So post will be the appropriate one to use here. So I'm just going to start by typing app post, and then I'm going to put my path, which is add book, and I'll create my function. I can actually put the book I want to add inside my function here like this, as well as a query parameter like we did before with the index. But there's also a different way to do this, which I'll show you later. So this one is going to be pretty simple. We're just going to take this and then append. We're just going to append the book. And then for the response message, we'll just have an acknowledgement that the book was added. Okay, so let's see if this shows up. If I go back to my docs and refresh it, then I've got this new post method here, and then you can see the color is different. These are 4 get methods, and then we have a post method. And if I open it up, I have my book parameter as a query string. So if I click to try it out, say like that, and then I add the Harry Potter, and I press execute, then you can see my message, book Harry Potter was added. In this app, we've actually just appended it to a list that we have in memory, so this book database list. And since the server is still running, nothing's changed it or reset that memory. I expect that if I list the books, I should be able to see the new book I've added as part of that list. So let me try running this, and you can see that Harry Potter was indeed added to my database of books. However, if I refresh the server or just restart it, shut it down and start it again, you're going to see that that entry disappears because that was only in memory, and then that just became lost really quickly. So if I just refresh this again now after restarting the server, and then I try list books, then my new book is gone. In a real API application, if I was building this out, then this book database would actually be something like more like a database connection instead of just a list in memory. But just to give you like a quick taste of how to persist data, for now, let's actually just save this to disk as a JSON file. So it's going to save to my project here so that we can actually have a database of books that doesn't reset every time we restart the server. So first I'm going to come up with a name for a file, for example, books file like this. And I'm going to make it a JSON file. I'm just going to save all this data into a JSON file. And I'm going to check that if this books exist, then I'm going to load data from it. Otherwise, I'm not going to do anything. So let's go ahead and try that. Oh, we'll need OS as well. So we'll import OS. If the book file exists, then I want to open it up. Open it up in read mode. And I'm going to need JSON as well. So I'll import JSON. So that's just a way to serialize our data. And I'm going to say that books database equals JSON load. Oh, I actually have to have a reference to this pointer. So I'm going to call this F. Load F. This will do nothing yet because I don't actually have this books JSON. So when I add my books, I want it to save to this JSON. Since the way to save a JSON file is quite similar to loading it, I'm just going to copy this chunk of code over here, move it down to my add books section, and then after appending it to my database, I'm going to open the books file as write this time. And then I'm going to dump the data. People in different languages and frameworks usually have words for JSON loading and saving information. In Python, it's dump for saving and load for loading. In other places, you might hear like unmarshal or serialize, deserialize. So yeah, that's just something to keep an eye out for, but they basically mean the same thing. Okay, so save that file and let's see if it works. Okay, so I've run my add book method again and it says it was successful. If I go back to my project, I see I now have a books.json that has this new book, Harry Potter, in it. And if I reload the app like I did last time, stop it and reload it, then it should load the JSON file on startup. So when I go back to my list books function and try it out, I should see that the book is actually still there. Okay, so that's good. Now I want to talk about something called a request body. So the situation we have here is now that we're adding a book and the book is just a string as a query parameter. But if this was a serious e-commerce bookstore, then this information is simply not enough. If we're actually adding a book, we're going to need much more information. For example, what genre it's in, what year it's published, what price we want to put it at, things like that. So if we just add a bunch of parameters here, that's one way to do it, but then this can become really long and not scalable. So what we'd ideally like is to have some kind of data model for what a book is, and then use that when we add the book, use it in our database, and then we can use it to do all sorts of things. So let's see how we do that. In FastAPI, or actually in just REST APIs in general, we have a concept called request body, which is if you send information to your post method, like this one, then aside from using a query parameter, you can also use a request body, which is basically a JSON object that gets sent with the request. And it's not visible from the endpoint, whereas you can see the query parameter here, it actually shows up in the URL. The request body will actually be hidden and you won't be able to see it. You'll be able to see it in your curl command, but you won't be able to see it in the URL itself. So with that, because it's a JSON object, the things that we can send can be much more complex than just a string. And the good thing about this as well is that the request body, because it's JSON, it means that your API can still be used across any kind of platform. So even though we want to define our book in Python as a Python data structure, people can still use this API as long as they can build a similar data structure, whether it's from JavaScript or C# or whatever platform that is communicating with this API. So let's get started by creating a model for what our book will actually look like. So I'm going to go back to the top here. To create a data model in FastAPI, we just have to create a class that extends from the base model object. So to do that, it's actually from a library called Pedantic, which we will already have from installing FastAPI. It's just Pedantic import base model. And then we can create the class like this. So I'm going to create a class called book, extend from base model, and now I can just define the fields I want. So maybe I want a name and it's going to be a string, and I want a price, which might make it a float. And I also want an ID. So this will help me identify the book in case the name of the book changes, or I don't want to look it up by the index. I just want a unique ID. So this can be an optional string. And the reason I want to make it optional is I don't want necessarily that the user of this API to pass in this information, but rather that we'll generate this ourselves when we add the book. So let's see how that works. And then from this, I'll also need to import this optional. So from typing, import optional. So this just means that it's not going to throw an error if we don't include it in the request. But I am going to default it to a unique UUID. So I've imported UUID here, and I'm doing this because this turns it into a string, whereas this is a UUID object. And now this becomes an optional ID string that defaults to a random ID number. And finally, I also might want something like the genre of a book. But with genre, I could use string, but maybe I don't want people to be able to type whatever they want. Instead, I want them to choose from a set of information. So to do that, I can use, again, from typing, I can use this one called literal, where if I do that, I can just define the exact values I want. For example, I can do fiction and non-fiction, like this. So now I have my book data model. Now at this stage, I'm gonna delete all the existing books information that I have because they don't fit this model. So let's start from a clean slate and just delete our book.json as well. So now we've got a completely empty book database to begin with. And now when I'm adding this book, I'm gonna make it add a book model data type instead of a string. It's the book, like that. As I said, when I add a book, I want to give it a new UUID. So I'm gonna just basically overwrite its ID, whatever it is, here, so that I have brand new unique IDs every time I add a new book, and then I'm gonna add it to my database. So let's see if this works. and I've got an internal server error. So something's wrong with this and it doesn't work. Let's find out what happened. And if you look at this, it says this book type that we've created with FastAPI is not JSON serializable. So when we try to save it using this JSON dump, this item that we've added here, we can't turn it into an item that JSON can understand. So to fix that, we can actually import something from FastAPI called a JSON encoder. We go to fastapi.encoders, import JSONable encoder. If we run this on our book base model, it will turn it into a JSON object that we can then add to our database. So let's do this again. I'm going to call this JSON book. And the reason I didn't overwrite this original book, like I don't do it here like this because I don't want to mutate the original meaning of this variable. Like for example, I might want to use it later as a book-based model, but generally I don't think it's a good idea to reassign values of variables anyways if you can avoid it. So I'm going to append the JSON book to the book database instead. I think I'm going to keep the book message here for now because I think that will be okay. But you know what? In addition to the message, I will also add the ID because thinking that if I add the book, I probably want the ID that gets assigned to it to refer to later. So let me just go ahead and add that there as well, like this. Okay, so now with this, again, let's clear out this corrupted JSON file and run it again and see if we can actually add the book this time. Just restarting my server because I think that this error was so bad that it couldn't recover on its own. Shut it down and restart it again. Now let's give this a quick refresh. And if I expand that, I can see the schema of the request that I need to send. And if I click on that, I can actually see more details about it. For example, these asterisks tell me which fields I need to send and which ones are optional, and also what type of information they are. So this is a string, this is a number, this is a string, but it has to be one of these, and this is also a string with a default that changes each time I use it. So let's go ahead and try it out to add a book and see what happens. Okay, so if I've executed this request, first things is if you notice the curl command, we can still actually copy and run this in our terminal. But what I want to point out is that the URL add book no longer contains any information about the parameters we're sending. So before we saw it either in the path or in the query as a question mark, but here it's sort of hidden away in this JSON body. Another thing to notice is that the book ID we've actually ended up adding to our database is different from the one we sent in the request. And that's because I want the database or the server actually to be authoritative about how it generates the ID. I don't want my users to be able to tell me what ID the book should be. In fact, this book ID field shouldn't even be visible to the request client at all. And finally, if we go back to our project file and look at our books.json, you'll see that the new book we've added is now here. Let's see what happens if we try to break it by putting in different details for each of these fields. So let's go back here again. And here, if you remember, the genre could only be fiction or nonfiction. Let me put something like drama like that and see what happens. And then if I execute it, I get a error 422 because my request was bad. So it tells me that I wrote drama, but the only values I'm allowed to write are either fiction or nonfiction. So this is a great way. By defining the model, you can actually control what kind of information your users can send to your API. So now we have implemented a method to add books, and books that we add here will show up in our books.json file as a nicely serialized JSON data structure. Now the last method I want to implement is a method to get the book given the book ID. And this is slightly different from our book by index because in this one we use a path parameter, and in this get book one we're going to actually use a query parameter. So the URL query will look like this, where we'll have get book, question mark, and then the name of our parameter and some value here. For example, this could just be some, or whatever this thing was. Let's just copy that. So this is what a query parameter will look like for get book. So to get started with it, I've just created the path of this method here, which is getBook, and we don't need anything else after it because this is going to be after this question mark. Here I can specify all the parameters I expect from the query. So I want one called book ID, and because the ID is actually a UUID4, which is a string, I need this to be a string. This is not a real database, it's just a list, but if this was a real database, then a string lookup in a database or a key lookup in a database should be fairly quick. For example, imagine a primary key in a relational database or a primary index key in a NoSQL database. However, because this is just a list and we don't care enough about the backend of this right now, we're just going to sort of brute force it and look at every element and find the book that has this ID. So I'm looking through all my books in the database, and if the ID matches this ID we're getting from our query parameter, we return that book as the response. Otherwise, if we don't find it, we can either return a message like this, saying that the book wasn't found. But I think the better thing to do here is actually raise an error so that we return a response with a 404 error code, which is the universal status code for saying that this item doesn't exist. It tried looking for it and it's not there in the database. So I'm just going to copy this HTTP exception that I used from earlier on and use it at the end of the loop here. So that's pretty much the implementation of this function. Now let's just go back and look at the docs and see if it shows up. Refresh this page. And now I can see this getBook API being created. So if you look at this, this is a required string query parameter, and I can try it out. And if I put in an ID, just some random text here and execute, it's going to be an internal server error. So let's look up why that is. Predict object has no attribute book ID. Oh yeah, that's because this is a JSON object and not a book model, so we probably have to do something like this. And let's try that again. Okay, so now it works. It says book not found and the ID that I put in. However, if I take an ID of a book that actually does exist in my database, like this one here, and then use it with my getBook ID and execute that, then this will work and it will return the book that I was looking for. That's pretty much all we are going to implement today. Let's just recap all the different methods that we've done here. First of all, we've created a home index method that if you just run it, it just sends a health check ping saying, hey, welcome to my bookstore, and nothing really significant happens there. Next, we implemented a list books method that if we run it, it'll return a list of all the books that are existing in our database. We also have a get method called booksByIndex, which accepts a path parameter here. So if we put in a number there, it'll find the book at that index. And if we put in something that's out of range, it's going to throw an error saying that the index is not in the range of our database. We have a method to get a random book. In my current database version, I only have one right now, so it's always going to return this one. But if we have more books, then it's going to return a random selection from there every time we call the API. We have a method to add new books. So here we have a schema that we have to submit with the query. If we try it out and we try to do something that the schema doesn't accept, then it will fail. However, if we follow the schema, we should be able to add a new book and have that show up in our database, for example, like this. And we made that this book ID field is optional. So if we remove it, then it should still work fine. And also we did that because we want the server to be the one to generate the book ID itself. So now we can add books to our database and it will actually show up in our JSON file like this. And finally, we have this getBook method that lets us take the ID of a book that we've added before, so something like this, which is guaranteed to pretty much be unique and never change, and then use it to find that specific book directly. And all of this functionality and all of these methods that we implemented as part of our API, we are testing it on our local server right now by running this UVcorn module to run our FastAPI application as a server, which is here. But if we actually want to deploy this to production or have it accessible on the public internet, we're going to have to find a way to take this FastAPI script and put it online somewhere and host it in a way that instead of having this localhost endpoint, we actually have a public URL or a domain name that we can use. And then it'll be the same as this, where if somebody hits a certain endpoint with the right parameters, then people can add books, remove books, or do whatever you want. So you can imagine where you can go with being able to build something like that. In my next video, I'm actually going to show you how you can host this API on the internet using AWS EC2 so that you can have an endpoint that lets you use this API anywhere and not just from your own computer. But anyway, that's it for this project today. You can find the source code in the video comments. I hope you found this useful, and thank you for watching.